I'm Dennis Ferris, and this is the Limitless Energy Podcast. It is my privilege to welcome my guest today, Mr. Steve Cotton, CEO of Aqua Metals. Thank you for joining.
Thanks for having me.
So Aqua Metals is in our space, in the lithium-ion battery space, but you're on the recycling end of it. And one thing I want to talk about is you guys started as a recycling company, but not in lithium. So let's go back to the beginning.
Yeah, so we founded the company in late 2014 and ultimately created a technology that we deployed right here in the Tahoe Reno area called...
I forgot to mention you're local, too.
Yeah, that's a good point. Yeah, we're right here in Tahoe Reno. We weren't originally, though. We were actually based in California, in Oakland, California. And so we developed this technology called AquaRefining, which is a super clean way to recover metal from battery metals in particular. And we started with lead acid batteries, and the reason we did that is because that was the, at the time, existing rapidly growing established battery industry, which is still there today, that is really reliant for the recycling on smelting. And smelting can sometimes rank in the top 3 most pollutive things that mankind does in the planet.
Smelting of lead acid batteries, like globally, is just an awful thing, right?
It is. It is.
So that's not the typical lead acid recycling methodology.
That is the currently only method that's commercially scaled at a grand level for the way that lead acid batteries are recycled. So the bad news is that there's room for improvement in the way that lead acid batteries are recycled. The good news is there's a technology like AquaRefining that we've developed that eliminates the need to do smelting and lets electrolytic and recyclable chemicals be able to recover those minerals without all the impacts on the environment. So that's how we started and developed that technology and deployed that right here.
So that was developed in-house at Aqua Metals?
It was, yeah. Yeah, and today there's about 74 patents globally for AquaRefining suite of technologies.
Okay, so when you're recycling lead acid batteries, it's basically just the lead that you're extracting out of the system?
Yeah, so unlike lithium batteries that have multiple metals that are in them, like the cobalt and the nickel and the lithium, of course, copper and others, the lead acid batteries primarily only have one metal that you're going after, which is the lead itself. It's a single mineral recovery is the main target. There can be a little bit of copper, and some very small side streams, but it's really all about lead. Okay,
so let's get into lithium then.
Yeah.
So why the transition to lithium? How did that come about?
So we didn't name the company Aqua Metals because we wanted to go after one metal. We knew that we were going to be building a suite of metals. So the Horizon 2, when we started the company, was ultimately lithium batteries are going to be produced and catch on, and EV revolution is coming. We knew that even in 2014. And second generation Teslas were already out, and we had on our plate to find ways to extract in a multi-metal environment, which is much more complex and complicated than a single mineral environment like we were talking about earlier. So we had some side stream research and development that was happening, and some of the patents that we even prosecuted, which includes things like the way that we remove the copper in the lead batteries to introduce better purity to the lead for the lead batteries. We started with that and then worked our way through the nickel and the cobalt and the lithium, et cetera.
So this really started so you're in the lead acid recycling area, and in order to better purify the lead, you started working on different metals at the same time.
Exactly.
Okay.
So that allowed us to really find a whole new market that is interesting because the lead acid battery market's mature. It's a $65 billion global industry already. And if you drive down the road and look at every single car, believe it or not, including EVs, because the low voltage battery in EVs is a lead acid battery typically, the 12-volt battery they call it. And there are a lot of them. And so that's a big industry, and it's a massive set of infrastructure that's been built that's out there to make that loop close. Now, the good news about the lead acid battery industry that the smelters we can thank for, believe it or not, is that about 99% of lead acid batteries globally now are recycled. And that's where lithium has some catching up to do, whereas in the lithium world, it's about 0 to 2%, I would say, of lithium batteries today are recycled.
Well, the 1% that aren't recycled are terrible. lead acid. That's why here at
Yes.
Dragonfly Energy we like to, our catchphrase is "lead is dead." We are trying to replace lead acid batteries specifically with lithium iron phosphate batteries.
Yes.
So that brings me to another point, which is typically for lithium battery companies, they're trying to get to the nickel and the cobalt. Those are the high value metals.
Yes.
So companies now, well, let's talk about recycling lithium. Let's
Yeah.
just talk about what are the different ways and how does the aqua metals way fit into that matrix?
Yeah, so there's really three ways to recycle lithium batteries that have been developed to date, primarily. One is called pyrometallurgy, also known as smelting. And specific to your question about lithium, the grand total of lithium that's recovered from the smelting process is zero. So the lithium gets burned and unfortunately
It
emitted into
goes
the
away when you heat
atmosphere.
it.
It
Okay.
goes away into the environment. And then it also, some of it ends up in what's a byproduct of solid waste called slag, which you tap these furnaces and then you pull off what's called slag, which is an amalgam of materials that you can't really separate.
And that's just landfilled.
And that ends up being landfilled. And so there's no lithium recovery with the pyrometallurgical smelting method that's really been around since the Bronze Age. So that's why there's been a technology that we've all heard of called hydrometallurgy, and which is like liquid chemistry, chemical based. And there's some emerging players that are working on hydrometallurgical recycling that are trying to commercialize and go through that process. And what that difference is you bring in a bunch of chemicals, kind of like in the mining world, and then you put that on the urban ore instead of the mined ore, and you leach it out, and then you create a leachate and then try to go directly to what are called the powders. And so that has its inherent set of costs because you have a lot of chemicals on the inbound that are toxic in the one-time use. And then on the back end of it, you have a lot of sodium sulfate, which is a byproduct of most hydrometallurgical processes. And that has to be either landfilled or, believe it or not, some companies have even publicly announced that they're going to put it into the ocean. And sodium sulfate is not a good waste stream, and it's costly, but it's also impactful to the environment.
Right.
And so those are the primary existing techniques. Now, the benefit of hydrometallurgy is you can recover the lithium and extract the lithium. So that's a great step forward, and we applaud all the companies that are working on the technology to do that. What's different about our method is it's more like electroplating connected to a hydrometallurgical process where we pull out the lithium and we recycle the chemicals that we use to do that, and then we selectively plate the cobalt and the nickel and the copper for those types of battery chemistries that are there.
So how do you selectively plate something?
So we have a technology that's part of AquaRefining. The name of the box that does it we call the aqualizer. And so it's kind of a play on words of the electrolyzer. It's the aqua metals electrolyzer, hence the aqualizer. And what the aqualizer has in it is a bunch of cells and plates, and those plates are working with the electrolyte that we get into there, or the concentrates that we specifically send to each one. Like the cobalt one is a little bit different than the nickel one, is a little bit different than the copper one, but there's still boxes that ultimately plate these metals. And then we can harvest those metals from that selective plating, and they plate them and drop out the impurities. So we ultimately end up with very high purity of each of the metal types, also with a very high yield percentage. And that helps with the economics. And we know that we can make new lithium batteries out of metals because that's how we do it today. We mine the metals and refine those to the point where they're in metal form, and then we create the ability to go to battery precursors and ultimately cathode active material.
So is it done sequentially, like you do first the nickel, then the cobalt? Or how
Yeah,
is
so
that?
we do it in a certain order, and we kind of keep that a little bit of a secret in the
Okay.
order that we do it. And that is an important aspect of our process, but it's all connected in a system from end to end. So our input is what's called black mass, and the black mass is pre-ground up lithium-ion batteries that looks a lot like a black sand, which is the amalgam of all that material. And then it goes through our system, and we dissolve it, and then we again recycle the chemicals that we use to do some of that activity, and then we create the concentrates that head to the various cells that then plate out the various metals. And throughout that process, we're also natively producing lithium in the form of lithium hydroxide, which, as you well know, is an interesting version of lithium as compared to lithium carbonate for a bunch of reasons.
Right. So this is unique that you are taking the batteries, getting not just the metals out of it, but also the lithium hydroxide out of it as well. And
Yes.
so that's of interest to us, obviously, for a couple of reasons. We want a source of lithium, not just a mine source, but a recycled source of lithium. But also, our chemistry, lithium iron phosphate, doesn't have nickel and cobalt in it.
Correct.
So if someone's smelting, are they going to get anything? Are they just getting iron, or what are they getting out of that?
So what happens with lithium iron phosphate batteries today is there's less smelting of it really because there's, like you say, there's really not much valuable material other than the lithium. And we know that when you smelt it, you can't get the lithium. So what happens is those batteries end up going into black mass producers that create the black mass that include the other chemistries. So there's soon to be household terms like NMC and all the various nickel, manganese, cobalt, and all the other various battery chemistries, and they will take the LFP batteries, the lithium iron phosphate, crush them, and put that material into the black mass that then just gets sent out to recover the nickel and the cobalt through the smelting process or through other hydrometallurgical process. So it's in a way a diluting factor of the more other mineral-rich types of batteries.
I guess you still get the copper out of it, and
some copper on the front end, correct? Because there's physical copper that can be pulled out during the crushing and separation process, and there's some more copper that's in that black mass that can be recovered by some of these alternative processes. We recover all of it from the black mass that we get, but that's really important, right? Because ultimately, you have to be able to close the loop with these lithium batteries, and we could talk a little bit about the percentage of material that's in new batteries versus old ones, from the mined material versus from old batteries, and that is a really important aspect of the closed loop and the ability to recover minerals like that. And with our method, being able to recover the lithium means we can make economics out of recovering lithium iron phosphate batteries and close that loop.
Well, let's talk about closing the loop and vertical integration in the state of Nevada. There's been a lot of talk, of course, here in the state. The lithium is here, but now a lot of us in the value chain have moved here. And I personally moved here 10 years ago because, among other reasons, there's a lot of lithium in the ground here.
Yeah.
So why did you relocate from California?
So we moved the company here to the Tahoe Reno area because it was the most sensible industrial center, kind of the up and coming industrial center, really, in the world, I would say. You drive out there and you see the earth movers and you see all these high tech companies building processes. And the county, Story County, has all the same rules with the EPA and all the various regulating authorities, but they're very pro-business and very supportive of building infrastructure and creating jobs in this area. And so we originally went to the EPA when we invented the lead AquaRefining, because the company, remember, was originally founded in California, and they even suggested to us, you might want to look at other states other than California because you can move more quickly, and you might even want to consider Nevada.
Actually, yeah, you moved to Nevada as a lead refiner.
We did.
Okay.
We did.
So it was not a lithium
at that time. Yeah, it was on the horizon to plan, but our actual activities were in the lead space at the time, developing that technology.
Okay, that's
which is now something that we license, by the way. We could talk about that too.
Okay. So the gigafactor was going up right around the same time? Or?
Yeah, really right around the same time.
Okay. Yeah, that was an exciting time for Reno, of course, because, I remember vividly when Tesla was looking around, and I think they settled on 4 different states, and Northern Nevada was in the running, and it was pretty mind-blowing when they decided to set up here. For me, I had been here for a couple years, so I was like, all right, finally, we're on the map here. This is going to be the center of lithium. Yeah,
and it really was a key step, I think, to make Nevada the center of lithium.
It was. We needed a big fish here.
And it's really the only state that has like all of the pieces of the ecosystem, the cell manufacturing, the recycling, the mining, et cetera, that closes that loop. And so that's what puts Nevada in a very unique situation and opportunity to really become, it's called the silver state, but it can also be called the lithium state.
It is now, for sure. Okay, well, licensing. You're planning to license the lead refining business then.
Exactly. So we productized from our learnings of operating and created a second and even third iteration of the product, and really productized our solution. And our first licensee is a deployment that we put in Taiwan. So there's right now a world-class demonstration facility showing the benefits of lead AquaRefining sitting in Taiwan. And that's an interesting location because that's where a lot of the growth in the lead acid battery industry still is, because there's more up and coming economies that are there putting more cars on the road, inclusive of EVs, whereas the US is a little flatter. And so we see opportunity for uptake on this new technology there, and we chose the path of being a technology licensor and equipment supplier and a maintenance and support kind of provider as an enabler, and trying to get the existing lead acid industry to upgrade and capacitize with this newer, better way of doing things. But in the meantime, we're looking at the the lithium industry differently. And one of the reasons for that is if you look at the value of lead and the cost of lead, let's talk about the cost of these metals. That's about $1,700 to $2,000 a ton. And if you look in the world of lithium hydroxide right now is varying between $60,000 and $80,000 a ton.
It was like 10,000 a year ago. Or 2
Yeah,
years ago.
yeah.
So
And so it's volatile, and there's lots of interesting debate. That'd be a whole subject for a whole other podcast. Is where do we think that the lithium prices are going in the future?
Right.
And we of course hope they go up because we produce the material.
And we hope
you
they
hope
go
they go
down.
down. So it's natural.
Well, what's driving that is, obviously you've got this incredible demand that's being forecast if every vehicle becomes electric.
Yeah.
Not sure how feasible that is. I personally, my personal opinion, I don't know how wise that is, because we want to get some of the lithium and put it on the grid, because we don't want to
Agreed.
stress the grid too much that everyone has an electric car that's charging off the grid. But anyway, I've been blabbing about that for a long time.
Yeah, and I agree with you on that there's a certain level of penetration that EVs can make, almost even neighborhood specific, before there's stresses that are put on the grid if everybody's trying to charge their car at the same time. And if they have more renewable energy source and local power generation and local energy storage to supplement that, that is really the yin and yang of electrification of the world. And so that's a really important aspect of the adoption of EVs, is what is the success and adoption going to be of home energy storage systems,
Right.
and corporate and data centers and all those types of applications.
Yeah. So some of that lithium's got to go on the grid.
Oh, yeah.
Some of it, if there's, other things can go on the grid too, but our view, of course, is that we need a lot more lithium to be distributed on the grid in people's homes and in buildings. So
Yeah, absolutely.
that's yeah. Well, I need to go there today, but
And other buildings, which is an important market even for you guys, which is the data center space.
Sure,
And you and I have talked about this, and I spent a lot of time with the data center operators, because that's where I came from before
Right.
Aqua Metals was the data center world. And what's interesting there is, if you think of a data center, think of it like a big gigantic laptop. You've got power coming in, you've got the computing power, and you've got a battery that sits there. In the case of a laptop, that happens to be a lithium battery. And then you've got, in a data center, big, massive generators, diesel generators that back up the power. So when the power goes out at the utility, it swings through that battery bank and then goes to the generators. The first generation of data center deployment, and these are hundreds of megawatts sometimes, these very large ones, so like almost the size of a town or even a small city, is the power consumption that a data center can consume. And that energy storage in the battery was just enough to be able to start the generators up, somewhere between 1 minute, maybe as many as 8 minutes. And if you couldn't get those generators started, then you would lose everything. So they've started by deploying lead acid battery systems, and then they've migrated a lot of them to lithium-based systems because they can get more runtime, they have more power density, and all those benefits that you have of lithium. But then the diesel generators are still there. The environmental regulators like less and less megawatts of diesel generators running all the time. So now the data center operators are looking at replacing those diesel generators with massive battery farms. So then they have hours instead of minutes of runtime in the event that there's a utility outage. And that is a space that I believe is where a lot of the deployment of stationary energy storage is going to end up.
Yeah, I think you're right. And there's just a push to replace diesel and, gas burning everywhere.
Right.
And that's been, of course, a big boon for us, but the data center market is something that we're looking at pretty seriously.
Yeah, makes a lot of sense.
So your background is in data centers. So explain how you went from there to, lead refining anyway.
Yeah, so my company that I built up in the past was called Data Power Monitoring Corporation, and then IntelliBat, and then ultimately we merged those two brands into a rebrand called Canara, like the canary in the coal mine. What we provided was battery monitoring systems on lead acid batteries for all these data centers, and we would monitor those batteries for reliability, so we would know that they would be able to work. Because if you have like 240 batteries in a string, lead acid batteries fail as an open circuit, and you really have one bad battery, you have no battery backup. So we provided that monitoring and the battery systems, and so because of that, when we asset managed the end of life of those gigantic, kilotons of these battery systems, we would send those off to smelters. And I started touring smelters saying, well, I want to learn more about where these are going and how they're being recycled.
Domestic smelters?
Domestic and even international. It can be appalling, some of these places that you see that, the worker environment is very challenging.
You taste the lead on your tongue?
Yeah, you could potentially. And there's lead in the air concerns for worker safety and people bringing lead home. There's lots of things that have been done to mitigate that, but at best it's a massive challenge, and it's kind of a dirty business. But at least you're recycling. And so that's the good news. But the bad news is you can't just say, oh, we're recycling, we got it all wrapped up. There's better ways to recycle. And then when I saw the AquaRefining technology that the founders had developed, I chose to actually invest in the company and then ultimately joined the company at the time as the chief commercial officer, and then ultimately became the president and CEO.
Got it. Okay. So who were the founders of
So the founders of Aqua Metals developed bipolar lead acid battery technologies, which is another way of putting together lead acid batteries, and it had a couple of exits there. They invented flow battery systems, which you might have heard of,
Yeah,
which are
lithium
very
flow
giant.
systems,
Yeah. So there's even lithium flow batteries, and there's even other chemistries.
Sure.
All kinds of interesting battery.
So they
chemistries.
were the inventors of the flow battery as well. The founders
Of one of the particular main kinds of flow batteries, and so they had a lot of experience with batteries, and they also had experience with environmental mitigation of lead in environments where lead needed to be removed from things like sand. Think of things like after World War II, all those lead-laden boats that went out to witness nuclear bombs getting blown off. They had radioactivity, and then they would wash the lead off, and it would end up in some sand somewhere, and let's go do an environmental mitigation. And they got the idea, well, wait a minute, that technology for the lead business could really make a difference and eliminate the need for smelting. And that was really the inspiration to create Aqua Metals to begin with, which is really interesting.
And now you're doing it all over again for lithium batteries.
Yeah, exactly. But what's different is with lithium batteries, we're building an industry from the ground up. And part of our core mission is to make sure that the world understands that we have a chance to, as we electrify the world, to build all this lithium recycling infrastructure that's going to be ultimately way bigger than even today's lead recycling infrastructure the right way. Because if we don't build it the right way, and we build it the wrong way, like smelting and other types of processes that have massive environmental impact, then we will have moved the problem from fossil fuels to electrification. We will not have solved the problem. And so what we're after is making sure that the way that these minerals, once they're pulled out of the earth, can be used over and over and over again is a clean methodology. So we've actually solved towards global climate change and carbonization, and our process helps to really decarbonize the world, as do EVs, as do battery energy storage systems, particularly those that are connected to sustainable clean energy sources. And so that's what we're really all about, is let's build an industry from the ground up that is built to last and solves problems.
Well, I love it.
Yeah.
You sound like a chemist or an engineer. What's your background?
IT.
IT. Okay. IT, and then you invested, and then you learned.
So IT way back when, too many years ago to count at this point. Management information systems, and I ultimately was born. I was born and bred in Silicon Valley, and grew up there and did high tech for many years, but lots with systems, voicemail systems, messaging systems. So I always really valued the hardware I'm much more of a hardware and a systems person than a software person. And so the act of recycling is really there's a lot of software, believe it or not, and firmware and remote monitoring things that are associated with it, as well as physical pieces of equipment. And so that's what keeps me interested is the integration of all these technologies to really solve big problems.
Yeah, it's funny as a battery company how we find ourselves going in the data and monitoring direction as well.
Yeah.
It's, everybody wants to know what's happening inside the battery, and of course that becomes a lot more important with larger systems, data center systems. So,
Absolutely. Yeah. Knowing like batteries are people almost, like they're all patients in an ICU. And you need to monitor each one of those cells and each one of those batteries to know its state of health and the trend of its state of health at all times.
Well, ours are not patients in the ICU. Ours are quite healthy, as
Yeah,
it turns
to begin
out.
with.
But we do want to. We prefer
The lead ones
we
might be
prefer
more
to-
in the ICU.
Ours is more of a wellness program. So,
I like that.
but anyway, thank you so much for coming on the podcast, Steve. And I know you didn't have to drive far, so we might have to do this again.
Yeah, it'd be easy.
Yeah, absolutely. So I look forward to the next time.
Yeah, me too. Lots more to talk about.
Thank you.
Thank you.
Well, that's going to do it for today's episode. Be sure to subscribe to the Limitless Energy Podcast on any of your favorite podcast platforms.